Okay, so the video projector is still warming up, but we can already start. So, this is the 12th lecture of software engineering methods, and today we are going to talk about a bit different thing than usually. Oh well, you probably see that I have different template on my PowerPoint presentation because today the topic is software testing. Last week we were talking about development methods, and 2 weeks ago the topic was use case analysis and going from the initial designs towards something more implementable. So if you consider the rational unified process phases, we are now in the implementation and starting to do the actual testing work. So there you go. So the topic today not only talks about what the software testing is in general, it also includes several observations collected from our research project, which focuses on Finnish software industry, and also what methods do they use, what sort of tools they use, what are their main problems, what's the concept of software quality, and what are the main things these companies do to try to ensure that their quality is acceptable. So basically, this is the outline of today's presentation. First, a couple of words about background, then introduction, concepts, what actually happens in testing, what's included in software testing. Our studies, recent studies, what sort of figures, what sort of amount of money or involvement or amount of work in general is involved in testing activities, and finally, if we still have time, we'll also discuss about the development, how organizations improve their testing work, how they find new areas of improvement, and conclusions on what to remember from this presentation. There's a possibility that we'll have to include the development and conclusion part in the next lecture, but if we have to do that, then we have to do that. So, why testing? Of course, testing is one of the activities in traditional waterfall software development. And testing is also the work which should ensure that the quality is good enough so that all the required things actually exist in the software. There's a really interesting number, the 21.2 billion US dollars. That's the amount Americans lost every year because the software products had failures in them. They behaved incorrectly or lost data or gave faulty results. And one thing you should observe is that this is actually 10 years old data. And if nothing else, then the amount of software in use has increased in 10 years. So 21.2 billion US dollars annually. If we take into account the second-hand damages, meaning the damages caused to customers or customers' customers, if we sell our software to one company, the damages that happen to the customers of that company because of our software. For example, if we sell faulty stereos to a car manufacturer and the people who buy that particular car have to take their car back because the stereos aren't working, that number is something up to 60 billion US dollars, not 59.5 to be exact. And this Jussi 2002 study is actually conducted by the United States government itself, one of their surveying companies. I now don't remember which one, but anyway, credible source. So that's a huge amount of money. And that's not just something crazy like having problems with having major problems with some components or things like that. This is just money that is lost because companies aren't investing enough in testing work. They aren't prioritizing enough working hours there. They aren't hiring enough people to do testing work. They are giving enough tools or suitable tools for people to get things done. Actually, even 20 years ago, this problem was known. There's a really excellent paper by Kitt in 1995, which more or less defines that testing is already the most expensive part of software development. Meaning that even though the amount of money involved in testing is varies between different industries, it's always somewhere between 30% and 65%. So in any case, testing is the most costly phase of development, and at least it's the second most costly phase. On some occasions, there might be possibility that if there's a development work, really heavy development work involved, or developing new technology before we can actually even do anything, then those costs may be up to par with testing work. Okay, so still, the actual amount of testing resources is always a bit of a discussion. The company will use the word optimal amount of resources in this presentation to present the amount of resources that the company thinks they need to fulfill all their testing needs. Meaning that if company thinks that they need 5 full-time testers for their work and they only have 4, then they would have 80% of their optimal amount of workers. Of course, this leaves some interpretation into the amount of resources. Someone might say that the companies don't have really good estimate on what's enough, but then again, we don't know the companies well enough to say that we don't know that they don't know. So this is the only way to actually measure the amount. But anyway, there's a study by Guan who says that 20% of the optimal resources defined by the company is actually usually enough to give adequate or acceptable level of quality in software testing if the organization uses those resources efficiently. They also mention that the testing work actually has huge influence on the actual profitability of the software product. It, besides taking care of the obvious faults, like the software keeps crashing or that the company has sold requirements that the software can't handle, there's also things like customer satisfaction, public image, for example, to take into account. The customer satisfaction here means that even if people are disappointed by the software or they consider that it's not cost efficient, They won't be buying your software again. So in the long run, you lose those sales on your next product the customer might want to have. Also, public image. If your company keeps producing quality that's not acceptable or not generally considered very good, you have problem. You actually end up with a problematic situation where you just can't do anything because people are automatically rejecting your software for something else. For example, this may not be clear to everyone here because this Tieto as a company produces mostly software for Finnish government, but that company has a track record which is considered really appalling. So every time government says that, okay, now we are going to order something new from Tieto, people already immediately consider that, okay, the software will be delivered over time, over budget, and it won't work when it's delivered because it's made by Tieto. So that's a really bad place to go if you want to have sales. So overall, these are sort of things are all stuff that can be addressed by testing. And we'll get back to the fact that how can we actually test something like public image or customer satisfaction. Okay, so considering testing itself, today's topic is a bit of a problem because there's a limit of something like 255 characters in our lecture system in Noppa, because today the actual discussion will include many things. We are going to talk about testing related activities, testing methods, different ways to do testing, how organizations' test process happen, what sort of personnel these organizations have, what sort of tools, what is test strategy, test case selection, policies, automation, different international standards, a couple of certificates, frameworks which are usable in software testing, maybe even something about open source, if I remember to mention those things. Anyway, we are going to talk about software testing in many ways that this lecture actually has ties to almost every other lecture we have already had. The software testing is not just a simple thing. Okay, so where does all this data come from? I'm giving here. Lappeenranta University of Technology, the laboratory I'm working with, actually has really long history with testing related activities and research projects with the industry. Our latest test project is more about quality, but the one which ended last year actually interviewed and observed 12 organizations from Finnish software industry, different sorts of companies, like from small 10, 5-man operations doing, well, some simple web interfaces or web service portals, to actually large national government-owned organizations, international companies, banks, insurance companies, stuff like that. Besides these 12 organizations, we also had a survey with 31 different software organizations, and we also had 10 organizations to give comments on our results or the data presented to you here today. So overall, this data is collected from the industry, and it's sort of validated by the industry because, well, many of those people who were given the validation interviews or given the data for reviewing said that this is actually more than enough, and can we keep this document? So, sort of thing. At the end of the presentation, there will be also this self-improvement framework thingy, which was tested with 4 organizations, and they liked it. So I guess that's a plus. Oh, sorry. So, well, this is more about the research work, but it's actually good to talk about also these things, because this is what the software testing research actually does. This project it was involved in identification and observation of different testing-related activities, how different testing models and methodologies would work in actual real-life organizations. So we had 4 interview rounds on these software organizations, and we talked with the people. Well, we asked questions and they answered. They gave long speeches or explained stuff from different viewpoints: project managers, testers, developers, software architects. So that if there would be one person who's only trying to sugarcoat everything and say only nice things about their company, then at least some other person would say something that's conflicting with them. So having several viewpoints into the same organization, so we can assess what actually happens there. So what our themes were? Well, design, development, testing, agile methods, standards, outsourcing, quality, test process, testing tools, customer participation, these sort of things. So overall, most of the things we have been talking about, software architecture, for example, on the 4th round, most of the things we have been talking about on this course. So, we came up with this definition. So, today when we talk about testing, we are talking about the organizational testing aspects. The organizational aspects mean that besides just conducting testing work by doing case after case after case after case with the software product, we actually talk about all the things involved with testing, things needed with testing, meaning that it's not only just one phase of activity, it's all these tools, methods, personnel, test case design, selection criteria, quality, and these sort of things. So overall, considering all these different topics, there's a large number of things to understand, and the important part is that if we, nicely, this one does not work. Well, the software process is this. This is the waterfall model. You have seen it several times during this course, and you know what it actually does. So we start with the collection of requirements. We make software architecture design. When we have design in a level where it can be implemented, or we are certain that this will work, we will start the implementation, do testing work, and then launch and upkeep. So overall, the traditional idea of what is testing is this. We start the testing work around implementation based on design, do some testing work, see that our implementation matches with the design work, and when we go to launch and upkeep, we actually are completed. We know that the software works, we don't have to worry about anything anymore. So, why the organizational aspects I said earlier? Well, this basically comes from the ISO IEC 29119 standard. It's a new, proud standard on software testing, aiming to give an definition for testing work which would be usable in all contexts, with different sorts of different company sizes, different domains. It actually points out that testing actually starts even before we have anything implementable. If we are designing software for a group of people, customers, we might want to test out our user interface in the design phase before we actually do the implementation, because we would be getting more detailed information for people. Also doing some sort of pre-testing, meaning that we might want to test our designs, test our requirements, for example, against the technical background of the system, technical resources or computing power of the target platform, so that we don't end up with problems. We might want to test the stability or accuracy of our testing tools themselves in design work, so that we know that when the implementation starts and we have to actually measure the work itself, we know that our tools give accurate results. We might want to define an test automation framework in the definition and design phase, so that we can create automated test cases, so that we have ability to cover more source code during the implementation. So all these sort of things are actually involved in testing. So basically, testing is not the second to last phase in development model. It's actually more or less the every activity, stakeholder, item or phase which has something to do with end product quality or definition of what we want to define. And on the organizational level, test strategy or test strategy, including actual test plan, should define what, where, who, why, when, and how software is tested. So basically giving the entire roadmap on how to create the testing environment, how to ensure that the customers can use the end product, how to ensure that we don't end up with the DVD player which has more buttons in its remote than normal PC keyboard, for example. These sort of things. So, considering also the fact that, like I have said earlier, testing is not only just creating a huge Bible of documentation and then letting people to work with it. It's actually, like all software projects, it has people involved in it, and that's what makes it really, annoying in a sense that we also, with people, we have norms, cultures, laws, roles. People don't like each other. They have hidden agendas, stuff like that. But it's actually something to remember that that test process is like software process. It has the social aspects, it has the cognitive aspects, information and mechanical stuff in it. So if we want to define, for example, quality, or we want to organize the test processes, we have to take into account several things, like what sort of laws we have in the country, especially if we are talking about patient management system or some tax system or European Union form filling application, we have to know the laws, we have to know the cultures, we have to, well, more or less be able to support the organization we want to, we want to sell our stuff for. We have people who have beliefs and attitudes and ideas and morals. We have, we also have people who may be really excellent at, with Linux systems, but have only a fleeting idea of how to use Windows workstations, stuff like that. And also, well, the usual stuff, hardware, software, these sort of things. So, from this picture, going back a bit to this one, we more or less have everything from the hardware stuff to management of people to actual having people competences and then trying to come up with some sort of quality criteria based on what we know about our customers. Okay, so if the testing work itself is a bit of a, well, it's something that includes many things, then what is software quality? We know that quality already is several things. It may be a simple definition as that, okay, I know the high quality. I can't exactly say what it is, but I know high quality when I see it. Is it the, well, with the furniture, is it the sturdiness or how much it costs, how nice it looks? Of course, looks are actually a really bad thing to measure quality because people have different tastes. Is it the cost effectiveness or how much one smartphone costs? Is one phone better than the other simply because it costs more, or can one cheap phone be better than the latest iPhone by simply costing the costs being less than half of new iPhone and still having almost the same functionalities. Considering from the other point of view, what does it mean for quality if we have high-grade components? How does that affect quality? If we are creating everyday product, but using high-quality components, something like using high-quality concrete, does that make our building more quality work? Or simply, how well it's put together from the factory production line. If we know that one factory produces every 10th product faulty, and the other one produces only 1% of the products are faulty, then of course the other factory has higher quality than the other one. So, in a sense, because the definition of quality isn't that simple, we actually are using this ISO IEC 25010 model for software here. Well, actually, it's not only just for software, but it's a generic quality model with different attributes and sub-attributes, which are more or less designed to be measurable stuff. I know that the problem with this model is that it doesn't take into account things like how fun the product is to use, or possibly even how much the product costs, but we have to be able to measure something. So let's say, for the sake of this presentation, that software product quality is a combination of transferability, stability, security, reliability, compatibility, efficiency, maintainability, and operability. So if we get all these things into high grade, then we quite probably have high quality product. Okay, so this is what we are aiming for. This is what the ragtag group of stuff we are trying to do it with. So what we actually want to say the test processes look like. Okay, so this is the ISO IEC 29119 model. There's huge amounts of stuff here, but the actual model itself is fairly sane and simple. I'll get back to that a bit later, but actually how the idea that the test organization works or how test activities are defined is simply that we want to create a test policy and test strategy. The test specification for the company organization to define what they want to have tested, when it has to be tested, who does the testing work, with what tools, and what are the quality requirements, and how much money we have for this every activity. So we start with the upper management. The idea here is that we collect people from the organization, project manager level people or really high-end expert analysts to compile the documentation based on stakeholder views, the current practices, organizational mission statement, IT policies, quality policies, everything that we actually think that might have something to do with the definition. And we make test specification, and here we have some sort of consensus on what we want to do, and then we give it to the organization. Here it's published, the test specification, which is test policy and test strategy. Okay, so it goes from the management level, which is represented here by this box. It goes to the project level, which is represented by this box here, the yellow and green one, and there's actually also another one here, which is not open, but basically meaning that the upper management creates this framework everyone uses, and then we have projects which apply the general guidelines, the framework the organization has. On the project level, we have test management process and we have fundamental test process, basically meaning the testing work itself. The test management process plans or creates the test plan, which is the everyday manual of what we are doing with testing work today. What are the test cases? What we want to ensure, what we are creating, how do we want to test stuff, and also monitors and controls the actual testing work, the fundamental test process, to see that the testing is carried out as instructed, and also that there's no immediate problems in the organization. The testers, the people doing the actual testing work here, do the test design and implementation, create the environment for testing work, do the actual testing which happens here, and report the incidents, meaning every little thing that might be a problem. And the list of things, test measurements, incident reports are given to the project level management, which then makes changes to the test plans. And when the project is done, we run out of things to test, creates a completion report and, test reports in general, and give it as a feedback to the organization itself. the higher level organization, which gets the feedback here, and then might do some minor updates, major updates, or do some revisioning work on the framework or, well, test specification, so that the next project, which starts later, can use the improved test policy, test strategy to create its own test plan, and so on and so on. And if there's different types of projects in the organization, then there might be several different test strategies, but anyway, each project level, each project follows one strategy, one policy, and gives feedback back to the upper level organization, which then may, well, improve those plans. So basically it means that the upper management, or management in general, gives sort of guidelines that these are the things we want you to do, these are the tools we want you to use, and the project level gives feedback on how well things work. Also meaning that the project level gets reassurance that there are these tools, there are these resources, and we are expected to reach this level of, well, these test objectives or this level of quality. It's more or less a, well, internal contract between the management and projects, if you want to say something like that. Okay, so the test policy, test strategy, test completion reports, and test plan are the four main documents of this model or idea. The test policy and test strategy are basically almost the same thing. That's why I talk about them as a test specification. So test policy and test strategy are more or less this high-level abstract definition of things. The test policy is something that should be understandable by everyone, even people who aren't software engineers, so that we have some form of documentation giving an idea about what's the required quality, what's the intended quality of things. The people from marketing or other places where they might not necessarily understand how difficult or laborious adding features or doing quality assurance is. The test policy is short. It's short enough so that you can shove it down the throat of your marketing manager if they want to release something 5 months before the initial deadline. It's something that's understandable by basically anyone, so that it's sort of a parachute or safety parachute for the test organization or software developing organization to show that we have these things still to do. The test strategy is the next step from that onwards. It's actually more detailed stuff. This is something that you have to design with test project managers or, well, development project managers. In general, it gives an idea on what practices we want to use: unit testing, test automation, explorative testing, black box, glass box, gray box testing, all these things. And it's a reusable set of guidelines. And it more or less says that, okay, we have this and this and this software available. It also compiles all the organizational resources, so that if we have a new project manager or new people in the organization, they can actually read through the strategy, and they can find stuff like the installation packages for tools or instructions how to use the version control and repositories and stuff like that. But it's not yet sorry, it's not project specific, meaning that it's more or less the list of the roadmap of testing work for all organization things. The test plan itself is the realization of strategy. It's the test plan here means the same as test plan everywhere else. It's the list of activities which are used to do the quality assurance, quality control work really. They are project specific. They use the ideas or guidelines from the organizational test specifications saying that what phases we have, who does what, the work divisioning, where our test cases are, how we manage weekly meetings, daily meetings, do we have nightly builds, what sort of a use for automation we will have, who will have the final say on releases, for example. Like I said last week in the Scrum lecture, in one game company, there's a separate quality manager who has absolute authority of saying yes or no when they ask about is this material good enough to use on promotion, or is this material good enough to send for publisher, or is this game good enough to send to launch or put publicly available. And that one quality control or quality manager can say yes, which everything goes smoothly and it goes out the door. But the more interesting part is that he can say no. And if he says no, no one is allowed to question that decision. The quality director has to explain why he says no, but if the quality director says no, then nothing from that project leaves that game studio. So these sort of things planned beforehand, and yes, overall give the guidelines on what to do. So, this would be kind of a crappy model if we were just giving the higher management a say to dictate what we have to do and then just try to live with that. We all know from from experience, from cartoons, that the upper management really doesn't have an idea what's going on in development projects. That's actually true. They don't know simply because it's not their job to know what happens if the one newest version of some older tool is worse than the earlier version. They are just doing their job, and their job does no longer involves doing the actual development work. So we need a feedback loop. Okay, so that's what the test reports and especially test completion report is. The test completion report is the fourth main document. It's more or less a report or autopsy of the project. It includes all the things, what was tested, what was not tested, how we deviated from the test specifications, why we did so, and how things worked with these deviations, possibly some recommendations for changes in the future way we do testing. These deviations may be things like that we ran out of time, we didn't have money to do this sort of testing work, our tools didn't support this feature, the new version of this one tool was broken, so we couldn't adapt it to our project, these sort of things. So, more or less, the list of things the organization testers were able to do, and list of things that they weren't able to do, and why they were unable to do things they were expected to be able to achieve. So, overall, like this. We have the organizational level and project level. We get overview, we get some ideas from the organizational level. On project level, we have management and control and actual test execution. We have people doing test work based on project level test plan, which is defined based on organizational level test strategy. The organizational level test strategy and test policy is developed based on test reports and feedback which is compiled from the incident reports and test case status reports. So, well, fairly simple. There's two levels, different things happening. These boxes here represent different activities. Test management process, test plan, TPP for example is test planning process. TMCP is test monitoring and control process. Different things the standard defines for people to do. These are more or less about the development of organizational activities, but we will talk about that next week. So, finally, the software criticality is also mentioned here. It's the same problem or the same scale of things. What's the worst case scenario? 1 being none or at most user irritation. 5, the loss of human life. I've been talking about this in at least 2 other lectures, so I just, skip this here. Just keep in mind that we might talk about also the software criticality. So, the first hour has been used on talk about the background and introduction of where this data came from and concepts of how we consider how in general these organizational test processes work, what sort of things happen when we do testing, what's the idea of this presentation for software quality, these sort of things. So now the idea is that we actually see if these ideas work in practice. Of course, you might already guess the answer if I would be giving a 2-hour lecture and saying that, forget it, it's complete crap, then probably this would be a bad idea. Okay, so starting with the amount of resources involved in testing. You might still remember the number $59.5 billion US from the amount of annual losses in the United States. And that was all because there wasn't enough resources dedicated to quality assurance and quality control work. So, we conducted a survey, 31 software companies from Finland or international companies operating in Finland, to see how much resources they put into the testing work if we know that there's not enough yet. So, to give us some sort of an idea on the scale of the organization, we asked about the amount of employees worldwide. I guess there's a 10 too much, but one company actually said that they more or less employ over 300,000 people worldwide, which would make it the Chinese People Liberation Army. But I guess the 35,000 is probably more correct. But anyway, the idea is that the amount of employees in these companies varied from several tens of thousands to just 4. Interestingly, on few of the software companies, the amount of developers and testers actually was 0. This means that the company does not employ developers or testers in their organization. They are a company which isn't in software business, but they get outsource people or insource from third-party companies, their groups, to implement their new services or implement their new software. Overall, the groups of people working in one local organization was 30 people, meaning that it's considerably higher than what was the amount of people in, for example, working Scrum or extreme programming cases, which was around 10 people. But anyway, this is the entire organization we are talking about here. The test automation, meaning that we have software tool which is more or less automated to take away all the need to manually click through every user interface or do the same tests again and again and again when we have to do when we make small changes to the software and we have to do all these things again. The amount of test automation was actually interesting because a few companies actually said that they have automated almost 90% of their testing work. Well, more understandably, there's several companies which do not use test automation at all because maintaining test automation is rather resource intensive. And if we don't have strong production line or one strong product, which we are just varying a bit for different customers, then there might be a situation where it's not economically sound to create test automation system. But anyway, many companies were also doing something automated. There was a 26% average and 10% median for test automation. So what the idea you should take from this number is that there will be most likely at least some test automation in software company if you are employed in Finland. Also, what was the amount of agile approach? The thing we talked about last week. Not only certain approaches like Scrum or extreme programming or test-driven development or any of those different keywords, but more or less the amount of projects the organization considered agile. There were actually few companies which had 100% coverage, meaning that they did everything in their organization with Scrum. There's actually one really interesting case. One government organization was doing everything by Scrum. But also some organizations which still did everything traditionally. The median number, 30% here, is actually confirmation of the observation on the last slide last week. The project-driven approach on selecting your development method. Companies actually do that. They do the main development of their main product, the new version of, for example, new main version of the operating system by waterfall approach, simply so that they get all the documentation base and all the other backtrackable stuff in place. But if they are doing something smaller, like adding feature or doing some small tailoring work to the software, then they are happy to apply agile approach simply because it's more simple and it has smaller overhead. The really interesting number here is the amount of testing resources against self-defined optimum. Here, reminding you that the calculation method is that if the organization has 2 full-time testers and they think that they would need 3 to get everything done in their organization, it would say that it's a 67% of the amount. Some organizations actually said that they have everything they need, no problem at all. And even the minimum number, 10%, says that unlike some sources which say that the amount of testing work is currently, or that the testing isn't trendy, the organizations don't value testing. It doesn't simply work that way anymore. The average amount of test resources was 70%. And we know from the first slide that 20% is the amount of resources you actually have to have so that you can do adequate or sufficient quality assurance work. So anyway, in Finland the average was 70% and median 75%, meaning that 3 out of 4 testers were employed, and the quality was actually something that the organizations really were concerned about. Similarly, the amount of time from projects, which is dedicated solely to testing activities, meaning that the organization focuses completely on finding bugs, fixing bugs, ensuring that the product works as intended, may get as high as 70%. Meaning that, most of the time is actually spent just testing the software. This is understandable in highly critical software. You really, if you are doing something like having automated traffic control systems for trains or something to do with aviation, you simply test it and test it and test it until your fingers bleed because, you want to ensure that it actually works. On the other hand, in few organizations which were doing, I actually don't remember anymore what they were doing, but anyway, they said that they don't have dedicated time for testing work. Everything they did for testing was done in parallel with the development until the day the software shipped to customer. So, it's somewhat confusing, but the median and average value of 25-27% says that, in general, 1/4 of the project effort is used in testing. The companies could probably enhance on this aspect. But on the other hand, we only know that 1/4 of the project effort is focused purely on testing. If they do some testing during the development, what are the amount? Of course they do some unit testing and stuff like that. That may not necessarily show on this number. But anyway, the quality assurance work, the quality control work is probably one of the most, expensive or time-consuming tasks in software work. So, going on, we asked our companies then, so what's the most, proficient things in your testing work. What are the testing areas you consider yourselves good at, or how good are your testing phases? So, as you can see from this graph, we start from the bottom of the graph, and we go from bottom to up here. So the unit testing is just the testing that the small changes to our module work and the module is still functional. The integration testing is the part where we try to put two modules together or several modules together. Usability testing, trying to see that the user interface is actually working. Functional testing, system testing, being more or less the entire system running together. And conformance testing is the last part, which is more or less quality assurance, saying that okay, our requirements and needs match to the actual product. So even though these numbers are quite close to each other, there's only 1 point difference between the best and the worst. It's still interesting trend that the companies consider themselves really good at doing high-level testing, meaning that they consider themselves to be really good at when the entire system is online, when they are able to do testing with the entire system. But when they have to do something during the development, like unit testing or integration testing, they are really, they are appalling. Actually, unit testing being on the negative side, say less than 3 means that most of the people said that these are not good. I think the scale was the traditional very bad, neutral, good, and very good. So unit testing being something that's actually considered bad here. But interestingly, it's really obvious based on this number that the companies we interviewed here didn't involve high number of game companies, because although the usability testing here is really low, we have conducted the same type of study with game companies, and the usability testing is the one thing they actually focus on. So considering that the usability testing is one of the most important things for game industry, and with the more traditional software industry, we get the results which say that the companies know that their usability isn't as good as it should be. Tells something about the focus areas of different software developers. Okay, so some more key figures here. So, does the testing stay in schedule? Well, yes, it sort of does. Are all the testing phases kept? Meaning that do the organizations use the waterfall approach, or if they are heavily into doing the testing in the final phases of the software development, are they willing to actually cut entire testing phases or most of the testing phase to get things launched in time? And well, the companies usually design their testing approach so that they at least do something on each phase. The testing does not have enough time. It's, well, here again, one of the on this graph, the worst figure, but on the organization of testing work, it's also one of the worst numbers. So testing runs out of time, but that's somewhat also understandable, because testing is the one thing that still happens before launch, and knowing that all products always have bugs in them. We may have the release conditions something like no serious or critical level errors anymore. The product functions and main functionalities are working. There's less than 5% of the money or time left, these sort of things. So overall, we always launch stuff with errors in them. So it's also understandable that the companies may say that they don't have enough time for testing because there's still something missing. Most organizations actually also identify the quality they want to have, meaning that they are trying to go towards some intended quality. This is, well, important in a sense that the companies also know what they should be testing, what they want to test, what sort of things they need to do to ensure that their products are considered of good quality and they get the next sales from the same customer. Okay, so also what sort of tools these organizations have? Well, you can see from this slide that actually testing work isn't really that tool intensive work. We have some test case management system, basically bug management databases, which just are used to control the amount of information about the problems related to the different faults found in the software. But it's not actually that much of a, well, tool-related work. Most of the testing work is still done with the same software that the developers use. For example, we had 32 organizations here, and there's only 9 cases of test automation here, meaning that even if there is test automation in many companies, they tend to just, well, do some automated scripting or stuff like that. And actually what is really worrying is that less than half of the companies actually have any test case management tool. So it more or less means that the companies are using email and Excel spreadsheets to manage their testing work. Well, it also means that we don't have to study any new or interesting version control systems, but I would say that there are more sophisticated tools than Excel spreadsheets and email to manage development of software tool in organization that has more than 50 people involved. Okay, I'm not going to go into these more open problems. I'll continue from this spot next week because we are actually running out of time. So we'll continue with the testing stuff, testing work, observations from the industry, what sort of things you should focus on when you want to understand how testing works or when you want to study the different testing methodologies and stuff like that to get experience which would be usable in the industry. But we'll stop here and I'll hopefully see you next week. Okay, you can go now.